My name is Todd Emrick, and I'm a professor here in Polymer Science and Engineering. And we're going to go to the labs to meet some people from my group. I have about 15 graduate students and postdoctoral researchers in my labs, and we're working in areas of polymer synthesis. I love making molecules, and so making monomers and polymers, all that lead towards new materials, is what we like to do. And so let's go to the labs and meet some of our people. So these are our laboratories, and let's take a tour and look at what we have. Most of my laboratories are for synthetic polymer chemistry. And so in this lab, we have students working on monomer synthesis, polymer synthesis. We try to design new monomers so they make polymers that are also novel in terms of their structure, but in terms of also their chemical and physical properties.
So I am a trained chemist back in India. So my goal was to work in a lab where I can actually make polymers and also study their applications. So in Emrick group, you have an opportunity to actually do chemistry and also do the application by yourself. So you can do the application by yourself, or if you want to collaborate with someone, you can collaborate from the department. And also because Todd is kind of like a guy who will encourage you to talk to other people from the other departments. So that's also a good positive point. You can learn a lot.
In this lab, Sarah Ward is working on polymer biomaterials. There's Sarah. Right, and so Sarah's actually working on polymer drug conjugates. So we take drugs, therapeutic drugs, and we attach them to polymer molecules and try to make them better, meaning longer lasting in the body, less toxic for areas where you don't want drugs to go, and then more toxic for areas where you do want the drugs to go. And polymers can help do that. That's what Sarah's actually doing right now as we speak. So in this lab, we look at the properties of our polymers in the presence of live cells. And so it's a very useful lab for doing cell culture with polymers. What happens when polymers and cells interact? Does a polymer enter the cell? If and when it does, where does it traffic within that cell, within that live cell? And so it's a very good lab for understanding the biological properties of the macromolecules that we make. Okay, so if we come over here, we have a different kind of lab. In fact, there's no chemistry done in this lab. It's all characterization, looking at the properties of molecules that we make. And then a very useful glove box. Liz Stubbs is in the box right now.
So this box is used for air-sensitive reactions. When we want to set up a polymerization, we can then set it up in here where there's no air, take it out of the glove box and analyze and characterize our polymers. So my research is focusing on flame retardant synthesis. So these are next generation polymers that are halogen-free and completely fully hydrocarbons that don't burn.
Again, we have another 4-person wet synthetic chemistry lab. We've got, that's Chris Quito. He's working on different kinds of structures.
Currently, I'm working on perovskites, nanocrystals, and other optoelectronic materials, and looking at the interface of these materials with polymers, and using polymers to help stabilize and aid processability. So the applications are far-reaching, so these can be used in LEDs, either for backlit displays or for electroluminescent devices.
So if we keep going with the tour, we come to the last lab. In this lab, we're looking at a number of types of polymer chemistry and synthesis. Hybrid materials, where we take synthetic polymers and look at their interface with hard materials, two-dimensional materials, graphene, transition metal dichalcogenides, things of that nature. And then polymers, again, that combine different kinds of structures. And so, for example, we have students working on polymers that contain fluorinated units with water-soluble units, taking two very different types of structures and bringing them into one polymer, and then learning about their fundamental properties. So that's what's happening in the laboratories in the Emrick group. Well, I really appreciate you and your interest in our department, in my group, and in everything we do here. So please be in touch with us. We want to hear from you and hear about your interests, and we look forward to seeing you in Amherst.